welcome to quickcode.com. It starts with kuickcod.com. So today we are looking at a difference between maximum and minimum price sum. So problem statement is here. So let me tell you the gist of the problem. Given n, which is number of nodes in a tree, right? And starting from 0 to n minus 1. And edges are given there, right? And then price is given there. So here number of node is 6. So starting from 0, there will be 5 nodes, 0, 1, 2, 3, 4, 5, right? And edges, there is a undirected edge from 0 to 1, from 0 to 1. So from 0 you can go to 1, and from 1 you can come back to 0. So all the edges are undirected. So 1 to 2, so 1 to 2, 1 to 3, 1 to 3, like that. And price. So index is the node value and this value is the cost. So this is the 0th index. So this is the 0th node, right? It corresponds to this node. And the cost is 9. So this is 9. And index 1, cost is 8. So index 1 meaning the node value 1 and cost is 8, and so on and so forth, right? So our task is to find the maximum path. So in this tree, the maximum path is this, and maximum path is determined by the cost, not by the number of nodes in the path. So what is the cost? 7 plus 8, 15, plus 6, 21, plus 10, 31, right? So this is the maximum path if we start from here. And then minimum path is only this, right? So 31 minus 7, so that will be like 24. So 24 is the value, right? We have to find such value and keep track of max and return the max, right? So now if we consider this as a root, right, what is the maximum path? Maximum path would be here, here, and here. And the minimum path is only this. So max minus min is only this path, right? So what is the cost of this path? Is 16. So earlier it was 24, now it is 16. And the max of this is 24. So the intermediate answer is 24. Similarly, you have to do the same thing, assume this one is a root, and find the max path and min path, and subtract min path from the max path, and then keep track of that of max value. So initially, when we see this problem, right, we always think that we have to look through all the nodes and apply DFS to all this node and find that path value. But this will take time complexity of this approach will be greater than of big O n, right? But there is a way to solve this problem in order of n, linear time complexity. So in the linear time complexity, we'll visit the nodes only once, and then we'll solve the problem. So how we can do that? So let's see a bigger problem. Here is the problem input, right? And this is the graph. So basically, this is we can think any node as starting point. Let's assume this one starting point. This has a children this, and it has one child this, and this has two child this and this, right? And this has one child, which is 4, and 5 has one child, which is 6. So this is the graph. Now, if we reduce everything written in the problem, then basically we need to find only, like, if this is the biggest path, right? And this is the maximum path if we start from here, and then if we subtract the minimum path, which is this, then we are left with this path, and we have to find the cost of this path, and keep track of such path, and keep track of max value, and then return the max value. So if we reduce the problem, then we can say that we can start from the leaf, and keep two variable, 1 and 2 path variable, right? And the two variables will hold the path value. And the first variable will include the leaf node, and continue add up all the nodes going forward. And the second variable will not include the leaf node cost. It will include the node after the leaf node, which is this one, right? Immediately after, and then continue add all the values, right? If we do this, so for example, this is cost is 8 and 7, right? So now say the first variable, okay, so it is including this cost. So 8 plus 7, 15 plus 2, 17. So I keep it 17 here, right? And the second variable will not include this cost. It will include this cost, right? 7 plus 2, 9. So 9 here, right? So this is a box because, sorry, here, 17 and 9. So, um, so till now we are here and we have one path from here to here, which is 17, and another path from here to here, which is 9 here, right? So now we have to similarly find the same thing here, right? One path from here to here, other path is only just this, and then we'll cross addition these two values, right? So what is the first path value, which is 9 plus 7, 16, right? Here I wrote it here 16, and the other path is only this 7. So I have 79, okay, and 16 and 7. So 17 is coming from here to here, right? And then I have to find up to this. So up to this, only this path is coming from the second value, which is 7. So 17 plus 7, right? So 17 plus 7, this is one value. Other value would be this path, right? Which is 9, right? And then 16. 16 is this. So starting from here to here, starting from here up to this, right? So which is 9 plus 16. Okay, so 9 is coming from here and 16 coming from here. So, and the max of these two is 25. So the intermediate answer is 25, right? So, and then when we backtrack, right, go up, right, we'll take the max path value from here, the path value from here and the path value from here, and we'll take the max of these two and then go up and do the same process. And finally, we already have like 25 as an intermediate answer value, and we'll check if there is a better value or not. And in this case, the 25 will be the answer. So we'll return the answer. So basically, we are doing one DFS call on this graph and then finding the answer. Now let's see in detail, like in detail calculation. So any node can be starting node. Let's start from here, right? So I make a one DFS call, start here, right? So this is the dotted line is forward tracking and solid line is backtracking. So on the dotted line, we will do nothing. On backtracking, we will calculate the cost. So we, on the recursive call, we are from here, we're calling this do nothing, call this do nothing, call this do nothing, call this do nothing, and then it has no child, right? Since it has no child, so it will return two values, right? Two values, which is in a array, like index 0 and index 1. So we'll just create an array and so two values will return. So one will include this cost and the other will not include this cost, right? So and then we'll go up and then we'll actually this is my running cost, and this is the current cost, and this is the running cost. Box is running cost and this is the current cost. So we'll assign this current cost into the running cost, and then we'll return this value to this. So this box value is the return value in this function. Now we have 8 0, right? And we have 7 0 here. So this is the current value because this is cost. Cost is 7, right? And comma 0 because we'll include and exclude. That's why we kept it 0. So now we'll cross multiply. So cross addition, right? 7 plus 0. 7 plus 0. This is one path cost, right? And the other is 0 plus 8. 0 plus 8. So max value is 8. So if the input value is this, only this, these two nodes, right? Then the answer will be 8. So we just finding the answer here, right? We're keeping track of the answer here and max value, that is. And now as we go up, before we return this value, we have to add this cost to the running cost. We have to add this current cost to the running cost, because we'll be building the path, two path cost from here, right? One will include this, other will exclude this, but start from here. So 7 is added to this cost. So this is we have the 8 and 0, right? This is the 8 and this is the 0. And then we are adding 7 to both of these, 7 here and 7 here, right? And then so now we have a 15 and 7, so 15 and 7, right? So before then this is the 15 and 7, and then actually we are keeping max value. We are taking the max from the previous. So earlier it was having 7 0 in the current cost, right? And then we have a new current cost, so we will take the max of these. So 7 and 15, right? Max is 15, so put the 15 here. And 0 and 7, what is the max? Max is 7, so put this here. Why we are doing this? Because it will be useful when a node has many children, right? So this is it looks like a binary tree, but it's not a binary tree. It can have other child as well, so it's a graph tree. So why? Because we are taking the max. Say for example, we are calculating from here to here, right? So we have got a path 10, and then say two path 10 and say 8, right? And if from here there is another path, say we are getting 12 and say 9, right? And from another branch here we are getting say 8 and 2, right? But we have to keep track of the max of all these three, right? And then we will go up with that value to the top. So that's why we have to do a max with itself, right? And with the current value itself, with the previous current value and the modified current value. So this is the original current cost, and this is the modified current cost, and we'll take the max of these two and then return this value to the recursive call on the backtrack. So now I'm here, right? So when I come here, so this is the value that will be returned here, right? So I have 2 0 and 15 7. So now if the input value up to these, then what would be the answer? So answer would be 2 plus 7. So I'll cross addition, right? 2 plus 7 and 0 plus 15. 0 plus 15. And what is the max value of these two? Is 15. So that is the answer, right? So basically what we're doing this, if the input is only these three nodes, then we are calculating the path, right, from here to here, and other is from here to here, and we're keeping track of the max. So this is the 15. And when we come here, right, then what we'll do, so we will add this cost to the path. So we have path from here to here and only this, and then we'll add 2 to this path. So now here, so 15 and 7, right? So this 15 and 7, this 15 and 7 which is returned, and this function got here, right? So this is 15 and this is 7, and now we are taking the cost of 2 and adding it here in both the values, okay? And then we are doing the taking the max of these two, these two and this value, okay? These two and this value, I'm taking the max, which is 17, and this value and this value, we're taking the max, which is 9, right? Because we have to take the max, because it can have many child, so we have to pick the max value only, keep here the max value only. So now after this, so we backtrack and we did these operations, right? So this is the line, white, and then it's white space. So from here it started forward track again to this child, right? So do nothing, and when we backtrack, we do the same thing here. So we have this current cost, then we assign the current cost to the running cost, right? And then we are moving up, we are building the path, right? So the path will include this and this, other path will only include this, right? So 9 0 and 7 0 will for cross addition. So 7 plus 0, which is 7 plus 0, and the 0 plus 9, right? which is here 0 plus 9, and the max is 9, right? So now here, so look, we come back on the backtrack up to here and did this operation up to this, right? And then we went to backtrack and then come back here, right? So we'll return this value to this node, and then we'll start processing from here. Now we have to find a new max because we are coming from this side, right? So basically what we need to do is we have a path, from here to here and here to here, two paths, right? So here to here, this path I will add with this, then we'll get one path from here to this, and then take this path from here to here and add with all these two paths. So therefore the path will be from here to here and take the max, right? So this is what is being done here. So basically what we have 17 and 9, right? And here we have 16 and 7. We will do a cross addition, 17 plus 7. Okay, 17 plus 7, this is one path, comma, 9 plus 16. So 9 plus 16, this is another path. What is the max? Max is 25. So now if the input is from here to here, then the answer will be 25, right? So now we have to now our current cost is 17 and 9, right? But we have a new branches here, so we have to check which one is bigger and then take the max path only, right? So from here to here, right? So 9, this is the 16, right? Then 7. So this path is 16 and 7. So now what we'll do, we'll add these two to these two values. So 16 plus 2 and comma 7 plus 2. 16 plus 2 is 7 plus 2, right? So we have, like, and previously this is the current cost, right? This is the current cost. All the boxes are running cost. So 17 and this is 18, right? And so this is 17 and this is 17, right? And this 17 I bring it here, right? And this is 18. So this 18 is coming from here, right? So I'm taking the max of these two, which is 18. I keep the 18 here. This is the 9. So I take the 9 and put it in here, and take the 9 from here, 7 plus 2, 9, and put it in here, and then take the max value here, 9, right? And then I'll return this. This is the running cost to this node, right? So this node will get this value, and this node, when I reach to this node, right? This node have a current cost 1 and 0. Then then we will get a new candidate answer. So we'll do cross addition, 1 plus 9, 1 plus 9, and 0 plus 18, 0 plus 18, right? So but answer is still having 25, so the max value will be 25 here, right? And similarly we will update this value, right? 18 and 9, which is coming from here, 18 and 9. So 18 and 9, and we add this cost because we are adding the cost and building the path, right? And then we'll do the max of this value itself, right? This value and this value and this value, take the max and put it in here, and this value and this value, take the max and put it in here, right? And continue, do the same thing. So when you come here, you will find the answer is 25, right? So this approach, a little critical, but it is very, very efficient, right? So let's see how we can, write this code. So let me put this one side by side. Okay, so now what we're doing, basically these steps are just creating adjacency list, right? We are looping through the edges and building the adjacency list. X points points to y, and y points to x because it's undirected graph. So after adjacency list, we have this DFS call get max cost, right? So get max cost, we are making a call only once and then calculating this path. So we are passing adjacency list price 0. 0 is the starting node, and then it doesn't have any parent, right? So I just put -1. So let's see. So now, um, okay, so I got, now we are creating a current cost, right? Price and zero, right? And this is the current cost. This is the current cost. This is current cost. This is modified current cost, right? And these are the running cost, and this cost is returned to this node. So this is my current cost, right? And then I'm finding the child of this root, right? And I got a child. So, and now if children not equals to parent, because if this is the root, right, and this is a child, the child has a reference to back to the parent, right? So that when we explore child, we will not go back to the parent. That's why we have this check. Now here we are calling the DFS function again, right? So so we we this is the method, this is the function beginning, and this is the recursive call. So and then this will be called many times as we go from here to here to here to here, right? So when you come here, then we'll return this 80. So this running cost will be, because this is the current cost, will and this will be returned as a running cost. So this is the running cost, 80 will be here, right? So now is the interesting thing. So now we have to do this max intermediate value calculation. So we'll do cross addition, right? So cross addition with current cost, current cost and running cost. So this is the current cost, right? And this is the running cost. So current cost 0, sorry, here current cost 0. Sorry, here we are taking the max here. So current cost 0 plus running cost 1, right? So from here to here, and only and other path is only this, right? And similarly, current cost 1, which is from here to here, and the other path is up to this running cost, which is equal to 0. So you can't see this one. So okay, so you can find this here, right? So the code is here. So um, now we have to do this max operations. We have to keep track of the max of itself, right? So we got this value, and we got a new value, after adding 7 to both of these, right? And then we'll take the max of these two and then put it here. So that's what we're doing. So current cost 0, math max, cost 0. So and then running cost, uh, 0 plus current price. So this is actually, see, we are adding this is the current price 7, right? We are adding 7 to both the places, 7 and 7. See, current price root, we are adding to both same uh, cost to both the path. So that now we can have two paths coming from each of the branch. One will include this node, leaf node. Other will not include this node, but start from here and then go up and then build up the path, right? And then here it will take care of the max value, and then whichever is the max, it will that will be our answer, right? So this max is a global variable which has been defined on the prop, right? Which is defined on the prop. So after this call, the max will have the answer, and that will be the answer. So if you want to see this problem, right, in detail, and then read this key clarifications and key insights, and then go through this code, right? So you can copy this code, and put it in here, and then run on this input. So you can write your own code here and run this input, run this code on this input, right? And you'll see the result. If we submit, right, then there are a number of cases that will be executed, and if all the test cases pass, then it will return success. So yeah, so this is it. And if you want to explore more, we have a lot of other problems, here on the dynamic programming, on graph, and then on combination and coin change, binary search. We have enough problem to practice in array. We have a host of problem on arrays, many tricky problems, find minimum in rotated sorted array something, you see all these are a lot of other problems. And we have like we have week 1, week 2 up to week 10, um, problems are there. It's coming from Grind 75 and Blind 75. So if you want to master data structuring algorithm, you can see this. And thank you very much and have a nice day. Bye.